Hi, are you designing and testing a regression model, but you know your dependent variable is not normally distributed and is rather highly skewed, which may prevent you from detecting relationships properly? I'm Dr. J from Modern Statistics. I share accurate and creative ways to analyze data using SPSS and SAS and provide guidance on how to interpret statistical outputs to help busy students and professionals like you so that you can complete your statistical tasks more quickly and more effectively. In this video, I'll share a few simple and easy ways to quickly transform your variables to follow close to a normal distribution so that you can use them in various parametric statistical tests. I'll use SPSS to demonstrate how you can quickly do that and show you the differences before and after transforming your variables so that your model properly detects relationships between variables. After watching this video, if you find this tutorial helpful, I kindly ask that you subscribe and click the notification button so that you don't miss important tips and tricks on using SPSS or SAS. Now, let's jump right in. Let me start with an example here and demonstrate how to transform the variables in just a few seconds. Here I have a histogram that shows the distribution of income measured in constant dollars. The histogram shows that the distribution here is positively skewed. By the way, if you ever get confused whether to call this positive skew or negative skew, just remember to do this. Tilt it clockwise like this. Then you'll see a shape of letter P. Then you'll remember that this is a positively skewed data. Okay. When you have a positively skewed distribution like this, you can try two different functions. One is to transform this variable using a square root function. Then the distribution will be a little closer to the middle like this. You can see that the standard deviation is much lower relative to the mean when you compare the before and after transformation. Now, the second method is to transform the variable using a logarithm, and the outcome will look like this. It appears the logarithm function is even more successful. Now, let's replicate this in SPSS. Here I am in an SPSS dataset that contains two variables. Let's first run a histogram on the variable income to view the distribution. Now, there are two ways to run a histogram on variables in SPSS. The quickest way is to right-click on the variable and choose Descriptive Statistics, and it will run the statistics right away. Okay, and the other method is the usual way. Go to Analyze, go to Descriptive Statistics, go to Frequencies, and here income will move it over. And since this is a continuous variable, we do not want the SPSS to generate a table for frequency list. It's usually meaningless, so we don't want that. Now, click on the Statistics button. Here, we'll just let SPSS generate the mean value and the standard deviation for us. Click Continue and click on the Charts button. And here, we want SPSS to create a histogram for us. And then we're going to check the box, which will show normal curve on the histogram. And click Continue and click OK. Then it generates the same information as before. Now, as anticipated, we see that the variable is positively skewed here. Now, we'll transform this using square root function in SPSS. Okay, to do that, we'll go to Transform. We'll go to Compute. Now here, before we transform it, we're going to give it a name for the new variable. And since we're going to use a square root function, we're just going to name it as Q underscore and the original variable name income. Okay. And then in the numeric expression box, we're going to choose arithmetic. When you do that, it generates the list of all the functions and special variables that are available under arithmetic. Now, let's scroll down and choose square root. Now, when you click that, it shows what function SPSS will use and describes what it will return. It will return the positive square root of that variable, which must be numeric and not negative. Now, to move this one over, we're going to click the arrow up button here. Now here in the question mark, we're simply going to put the income variable there. That's it. That's all we need to do. And click OK. and we have created that variable. We're going to right click on this variable and then run the histogram again. Now the distribution appears to be more normal than before, and which isn't surprising. Now this time, let's use a logarithm function to see if it makes it even better or not. So we're going to check it out. Now we'll go to transform, go to compute. Now here, since we're going to use the logarithm function, we'll just say LG underscore income. Now here, the routine is the same, arithmetic, but instead of square root, we're going to choose the logarithm LG10, and then we'll move it over there. Now here, again, simply put the variable income over there, and that's it. That's all we need to do, and click OK. And so we have created this second variable. Now we're going to run a histogram on this variable. Now it appears to be even more successful than compared to the square root function. Okay. Now, what if a variable is negatively skewed? So far, we've been looking at variables that are positively skewed. But what if a variable is negatively skewed? For example, let's look at the second variable named nice person. This variable measures how people would evaluate themselves on how nice they think they are as a person. So first, let's run a histogram on this variable. And as you can see, perhaps not surprisingly, more people rated themselves as extremely nice. Now, let's use a logarithm function to transform the distribution of this particular variable. To do that, the routine is the same. We'll go to transform and compute and just reset it. We're just going to LG underscore just nice person. Okay. Now here in the numeric expression, the routine is the same. Choose arithmetic and choose LG10 and move it over. So far the same, right? Now in this inside the parentheses, what we need to do is, here's what we need to do. We're going to put the largest possible value of the variable nice person and add 1 there, and then minus the variable, which is how nice are you, this variable right there. So that's the whole formula. So we need to find what the largest possible value is inside the variable of nice person. Now let's see if we'll first have to get out of this table here and find out. The quickest way to find out is right click on this variable and then sort descending to find out what the largest value in this variable is. Then we find out it's 12. Okay. All right, so what we need to do is go back to transform, go to compute here, LG nice person, right? And here arithmetic LG 10, move it over. Now here the largest possible value was what? 12, and if we add it, it's 12 plus 1 minus that variable right there, move it over, then we are done. 12 plus 1 minus the variable. Click OK. And we have created this variable right here. Now we're going to right click on the variable name and run a histogram. Not as pretty as we would like it to be, but compared to this, the distribution appears to be less skewed and perhaps a little more normal compared to more dramatic peak here. So that's what we have here. When you have skewed variables like the ones we saw earlier, people sometimes quickly abandon the use of parametric statistics, such as Pearson correlation, analysis of variance, or regression, or just ignore the non-normal distribution and just use it, force it, right, in parametric statistical tests, which would be wrong. Or people can instead choose non-parametric alternatives such as Spearman's rho. Well, you don't have to abandon it when you can quickly transform them, which is to mathematically modify the scores using the formulas that we used here until the distribution looks a bit more normal. Hope this was useful. Thank you for watching. Hope to see you next time.